Right. So, ladies and gentlemen, good morning. I hope everyone is doing great this morning. And also, at the back of your mind, you're hoping that the session might finish early today, and so that you can continue with your carnival festivities. I will try to facilitate that. We do hope that we will finish before 11 so that you can go and continue the merriment that you're in the mood for. But thanks very much for coming out today on a Friday morning just before the carnival. um, I have 24 people in the meeting and it's 3 minutes past 9, so I guess it's time for us to begin what we need to do today. So, as you're aware, folks, we are in topic 2 and we are discussing at the moment chapter 5. When we met last time, we had talked about the risk structure of the interest rates, where we had discussed different type of risks and their effect on interest rates. And when I say interest rates, the what I mean is the yield to maturity, basically. So though you're seeing in written format here on the screen also interest rates, basically what we mean is the yields, right? So the distinction is important so that you don't confuse between the coupon rate and the market rate. So whenever we are talking about interest rates here, it is about the yield, unless otherwise stated. So from chapter 3, you would recall we had discussed two type of risks and their effect on the interest rates. We had talked about the interest rate risk and the reinvestment risk. Then in this chapter, the first part of this chapter, we had talked about the default risk, which was the probability that somebody will be unable to repay or have a delay in repaying what they had borrowed from you. How would that affect the interest rate or the yield on a particular instrument? We had taken an example where we had compared a corporate bond with a treasury bond, and we had seen that how when people believe that a treasury bond might be a safer bet, they would want to gravitate towards that direction, which will increase the demand for that bond. And an increase in demand would increase the price for that bond, and that would cause a fall in the yield for that bond, because we know that prices and yields have inverse relationship. So relatively speaking, then corporate bond would have lesser demand, lower prices, and therefore correspondingly higher yields. And the difference between those two yields, that is the yield of the corporate bond and the yield of the treasury bond, that difference, we had given it a name, we had called it the default risk premium, because a corporate bond would have to offer a higher yield to attract customers, because otherwise customers are moving towards treasury bonds, which are safer. And through a similar argument, we had also discussed the liquidity risk, that a bond which would be more liquid would have lesser liquidity risk, and therefore that bond would be in higher demand with a higher price and a lower yield. Conversely, the counterpart, the other bond which has lesser liquidity would have greater liquidity risk, and for such a bond, the demand will be low and the price will be low, and therefore the yield would be higher. And the difference between the two yields again would be called liquidity risk premium. Then we had gone on to discuss the effect of taxes on interest rates, and we had taken up an end of chapter problem also, where we had compared a corporate bond with a municipal bond, and we had calculated the after-tax income from the corporate bond and then the after-tax yield from the corporate bond, and decided which of the two bonds would be a better purchase for us. This morning, ladies and gentlemen, we begin with the second part of the same chapter, chapter 5. And instead of risk structure, we are going to talk about the term structure of interest rates. Ladies and gents, before I begin today, if you have any questions that you have in mind from previous discussions, you are please free to ask those questions and clarify your doubts. So I'll be quiet for a few moments. If you have a question, you can just send me the question in the chat box, or you can just pick up the mic and speak. No questions, folks? Everything seems okay. All right, so if you have no questions, just in case if something pops up in your mind, if you think that I'm going too fast or I'm going too slow, if you can't hear me or if you can't see the screen, or if you have any other academic question, just interrupt in between and ask. Right, so let me scroll to the next page where we will begin today's discussion. So this QR code for your attendance will remain on display for the next 2 or 3 pages. For someone who joins in late, you can just scan and record your attendance. Right, so what I've pre-written some things for you here in order to save time. What I've done at the moment here is that I've defined what the term structure would mean. And as you can see from the display, it would be simply a study of a relationship. And when we think about a relationship, there have to be two things to be related, right? So there are two things, as you can see. One of them is time, and the other is the interest rate, which we are understanding as the yield, basically. So a study of the relationship between time and yield is what the term structure of interest rates means. What you see after this little definition is, and I've underlined that in red, is empirical facts about the term structure. I am not sure at this point in time whether everyone here in the audience understands what is the meaning of the word empirical here. Empirical. If you know the meaning, it's good, because now we are not face to face today, so I don't know what everybody feels, because I can't see anybody's faces. And so I can't really make up my mind how many of you seem to know. I can't ask you to raise your hands and show me how many of you know the meaning of this word empirical, how many of you don't. So for the benefit of everyone, I'm just going to make a remark here. Empirical means, yes, Mercedes, you wanted to say something?
I think empirical, because we'd have done something like this in a formal course. That's usually like if you have any specific observations, so
Mhm.
that would allow your research to have like its evidence based, so it's more
Yes.
objective.
Yes, Mercedes, very well said. Thanks for that input. That is what I was about to write here as well. Empirical would be something which is based on observations, based on observation. So I have observed that this happens in real life or in the marketplace. So if it is my observation, not only a single observation, but I have observed the same thing happening again and again and again and again and over a period of time, so that I have begun to see or identify a particular pattern about this thing, then that observation becomes an established fact that this does happen, right? So from observation, we move into a fact which is based on, as Modest was just saying, empirical observation, empirical evidence, basically, or observed evidence. So let's just write here empirical as something which is observed. So based on your observations again and again repeatedly, if you come to a certain conclusion that this is something that happens in real life and in a marketplace as well, then that thing stands as a fact. So about term structure also, three things have been observed repeatedly over periods of time. Economists have collected data for a number of years. So they have had a long time series, 10 years long, 20 years long, 50 years long. And when they analyze and study for patterns in those time series of interest rates, what they have found repeatedly is these three facts that you're seeing on your display. And I would encourage you to remember these three facts in the same sequence as you see them on display, and remember them as fact one, fact two, and fact three. Right, because later on in the discussion, if ever we need to refer to a particular empirical fact about term structure, it would be easier to refer to them as facts one, two, and three, but then your mind should point towards the particular fact in question. So if I say fact two, your mind should go to the second sentence that you see here under the empirical facts classification. So the first one is that interest rates for different maturities move together. Folks, stay with this sentence for a couple of moments. What does it tell you? Interest rates for different maturities move together. move together. Let's underline this. Interest rates for different maturities also. Let's put this under the spotlight a little bit. Different maturities. So what do we mean by this basically? Different maturities means, let us say there is a bond which is going to mature in 5 years from now, and there is a bond which is going to mature in 20 years from now. So both these bonds have different maturities, right? So the time remaining to maturity is different for these two bonds, and that's what we are talking about this morning. See, the first variable here is time remaining to maturity. So this bond A and this bond B, both of them have different times remaining to maturity. But what the first empirical fact is telling you is that the interest rates on both of them, that is the yield for bond A and the yield on bond B, both these yields are going to move together. What does moving together mean? First of all, what we should be careful about is to know what it does not mean. It does not mean that the yield for both these bonds will be the same. So it is not same. Yield of A and yield of B are not equal. So that's one thing that we should remember. But they are moving together means that they are moving in the same direction, which means that if yield on bond A increases by a certain amount, we can expect that the yield on bond B will also increase by a certain amount. They will both move in the same direction. That is what is the meaning of moving together, right? So if one of these yields was falling, the other one would pursue the same direction as well, right? So that way we can say interest rates for different maturities tend to move together or in the same direction if that is more convenient for you to remember. As soon as if you feel that there is something that you don't understand or you need to ask a question or clarify, you will please interrupt me. Let's move to the second sentence, second empirical fact about the term structure, which says that yield curves tend to have a steep upward slope when short rates, which means short yields are low, and a downward slope when short rates or short yields are, there's some typing mistake here. I will have to correct that for you. So let me get my red ink and make the correction. When short rates are low, this is correct, and this should have been and this should have been high, right? So make these corrections, please, at your end. Yield curves tend to have a steep upward slope when short-term rates are low and a downward slope when short-term yields are high. So let's understand what this sentence means. First of all, let's put this item in a box here. Yield curve. What is a yield curve? Yield curve, ladies and gentlemen, is something as simple as a time plot of yields. So if you were to draw a graph, it would look something like this. Let me scroll down, make space for myself, and just try to scribble in a graph here. Something that looks like a graph. So on the x-axis, we have time. On the y-axis, we have yield or interest rate. And we say time 1, time 2, time 3, and here are our different yields, and here are our locus, various points here. If we connect the dots here, this will become a yield curve. So it's basically just a time plot of yields. Now, what does the empirical fact say about this yield curve? Let's break it down into two parts. Let's just color code them so that it's easier to look at. Yield curves tend to have a steep upward slope. Steep upward slope. When short rates, which is short term, well, something, look at the yield curve here, something about here within a year is about short term. This is short term. And if we move beyond this to, let's say, about 5 years or so, this is from this point onwards till here, maybe it's medium term, though it can be subjective. And after this, so this can be labeled as something called long term, right? So what the fact is saying is that we will observe a steep upward slope when short term rates are low, right? So this is the first part of the sentence. So if we do a yield curve again here, and we have time on the x-axis, and this is our short term within a period of 1 year, and if this guy is very low somewhere here, then you can yourself see visually that there is only so much you can go low. You can't fall really below zero. Or sometimes in some economies we have had experiences of even negative interest rates, but then that will again take it further down here, maybe again negative interest rate. And as you move out in the future, if you're already too low, then there is only one way to go, and that's up. So we can expect that if we are already too low in the short term, as we approach the higher dimensions of time, the long term, then the rates might pick up and move in this direction. So the resulting yield curve would have an upward slope. You'll see an upward sloping line like this. That's the meaning of the first part of this sentence. Now let's change color and look at the second part of the sentence. And it talks about a downward slope when short rates or short-term yields basically are high, right? So an opposite kind of a diagram. So if on this side we have time, let's just clear out the mess a little bit here. Let's just take out this arrow and so this is our time and this is our yield here. So this is short term, and then up till here, maybe it's medium term, and beyond this is long term. So if the short term rate or the short term yield is too high, maybe at the top of the line here, maybe. So this kind of acts like a ceiling. If you're too high already, then also from the top, if you're at the pinnacle or apex or at the top of something, then there is, just imagine you're standing at the peak of a mountain top. I mean, then there's only one way to go. You have to go down. So we are expecting that if you already have reached the top, then you are probably going to go down in the future, and you will see a downward sloping yield curve. So in totality, this figure here, this one here, number one, and this one here, which is number two, these two kind of capture the second sentence that we have just read, or the second empirical fact that we have just seen, that yield curves will have an upward slope when short rates are low and a downward slope when short rates are high. Ladies and gentlemen, at this point, I would like to ask you if you have any questions, if you think I'm going too fast and you want me to reduce my pace, or if you think I'm going too slow and you want me to increase my pace, or if you think that you have missed out on something and you want me to repeat something, please let me know. Jara, your mic is open. Did you want to say something? Oh, you closed your mic. It was open by mistake then. All right. The third empirical fact that you see there on the list is that yield curves are typically upward sloping. So if we change color here again to orange, maybe, so this is the typical scenario, right? So read the third empirical fact as whatever suits you better. Yield curves are typically upward sloping, or generally upward sloping, or mostly upward sloping. Right? So whatever word you feel comfortable with, you can use them. Now, folks, let me clear out the mess that I have made with the typed material here, so that this leaves you with the three facts in a clean way, so that you can read them again. Spend a few seconds or a few moments with these sentences and remember these facts in the same sequence as you observe them on the screen. So that when I say in the future fact one, you should immediately understand that I'm talking about that interest rates for different maturities move together. And when I say fact two, we are talking about the slope of the yield curves in two scenarios, when short rates are low and when short rates are high. Though I had cleared the mess, this correction still stands. This is high, and this is end. And when we talk about the third empirical fact, we are talking about the fact that most of the times yield curves would be upward sloping. Right, so let's move ahead from this point. What we have said here, look at the black, my scribbling in black ink where I wrote about the something being an observed fact, basically. So these empirical facts then are telling us that this is what happens, and this is what has been seen as happening in the real marketplace. But if you have a curious mind and if you are a researcher in your head, then you would not be satisfied with simply the observation that something happens. You would also want to know, you would want to go to the next step and ask the question, why, if something happens, what is the reason for this, right? So simply observing something doesn't really solve the puzzle. What we need to do, and as you can see again, if you're just joining in, you can use the QR code again to mark your attendance. um, what we need to understand is why things happen in the context of the term structure. What is the reason? What's the cause? And to understand the reason or the cause, there are three schools of thought. Let's put them in a chart here. One way of thinking, or one way of school, one school of thought is classified as something called the pure expectations theory. We'll talk about each one of them. Pure expectations theory is the one which takes most time. The other two are finished comparatively faster. Pure expectations theory is one way to think about it. Then another way to think about it is market expectations theory. And the third way to think about it is the liquidity premium theory. Premium, right. You can correct the spelling here. Right, so these are the three ways of thinking about why do we observe such kind of facts about the term structure. Pure expectations theory, ladies and gentlemen, when we look at it, we haven't talked about it as yet, is going to be successful, is going to be about 67% successful in explaining why things happen the way they happen, right? Why I say 67% successful is because they will be successful in explaining two out of the three facts, facts one and two. So now I hope you will remember what these facts are. What is fact one and what is fact two? Market expectations theory is going to be about 33% successful in explaining why things happen the way they do, because it will be able to explain only fact three of the term structure. So then, once we know that this is 67% successful and this is 33% successful, why not meet halfway and combine the features from pure expectations theory and market expectations theory to come up with some composite theory or a combined theory which can explain 100% of the term structure, which will be the liquidity premium theory. It will explain all three facts because it will borrow a little bit from the pure expectations theory, and whatever is the balance that will be borrowed from the market expectations theory. So facts one, two, and three all will be explained. So somebody looking at it for the first time may very well ask the question, if there's only one theory that's going to be able to explain the term structure of interest rates, then why bother with the other two? I guess you already know the answer, because liquidity premium theory is not something original on its own. It's basically a combination of pure expectations and market expectations theory. So unless we know what lies here and what lies here, so we won't know what are we combining to get this, right? So in order to reach the liquidity premium theory's conclusion, we will have to begin with the first point of departure, and that's going to be the pure expectations theory. So let's begin with that here. I'm not going to go into the mathematical derivations of the pure expectations theory, but as I had said at some earlier time as well, if there is somebody in the audience who likes to see mathematically how things fall in place, I have a short video on that on my YouTube channel. You can see the math behind the pure expectations theory. Or if you want to talk face to face, you can come see me in my office. I can explain that to you, the mathematics behind it. But in this session, we are going to look at the practical application of, or the basic conclusion of the pure expectations, what it means and how it can be applied. Pure expectations theory. I have to keep these distinctions. I hope you understand that this is really not a math class. So though the background comes from mathematics, as far as possible, I try to avoid it and focus on the substantive part, which is the theory itself and what it says and how it is applicable. So pure expectations theory then. Folks, first of all, because it's a theory and you are aware that most theories are always based on some assumptions. So the assumption here is this. The assumption is that bonds of different maturities. Now, I need not demonstrate that to you. We have done this earlier, what different maturities means. So if bond A is going to mature in 5 years and bond B is going to mature in the next 20 years, they are two bonds which have different maturities. And the assumption that underlies the pure expectations theory is that such bonds which come with different maturities are perfect substitutes of each other. Bonds of bonds with different maturities, different maturities, maturities are perfect substitutes. Now, anybody in the audience from economics very clearly knows the meaning of perfect substitute. If you're not sure, it simply means whenever you find yourself in a situation where you cannot make up your mind whether to select item A or item B, and you're really indifferent between them, then you've encountered perfect substitutes because both of the items give you the same level of satisfaction and both items have the same utility for you. So, for example, if I were to visit you at your home and you were to ask me, Dr. B, what would you like to have? Would you like to have a cup of tea or would you like to have a cup of coffee? And if I say either one is okay, I'm equally fine with both of them. So it's up to you. Then, in my mind, a cup of tea is just as good as a cup of coffee, and no matter what you serve me, I'm going to have an equal satisfaction out of either drink. So then, in that sense, then they would be perfect substitutes of each other. So now, having known the meaning of perfect substitutes, look at the sentence again and the assumption itself, which says that bonds with different maturities are perfect substitutes of each other. What does it mean? So in our coffee and tea example, why was I able to say that a cup of coffee is just as good as a cup of tea is because the satisfaction or the utility derived from the drink was the same from both a cup of tea or a cup of coffee. So now let us say you have a bond, a 5-year bond, 5-year bond. This is a cup of tea, right? And then you have a 20-year bond. This is a cup of coffee. Why will I be indifferent between a cup of tea and a cup of coffee? Because I equally like them, and the utility or the satisfaction or the quote unquote kick that I get out of both is the same. Um, what is the kick that you get from a financial instrument then, right? Transfer your understanding from a drink to a bond, a financial instrument. What do you get? What do you expect to get out of a financial instrument? You are expecting to get some return out of this, and you're expecting to get some return out of this. So you're expecting to earn same return here and the same return here. So if you ask me, if you're Dr. B, you will be investing for the next 20 years, what do you like? Would you like to invest in a 20-year bond one time today itself? Or would you like to invest this way? Invest now, this one will mature after 5 years because it's a 5-year bond, then reinvest. The next one will mature in the next 5 years, then invest again for the next 5 years, then invest again for the next 5 years, right? So in all, it makes what? 5 plus 5, 10 plus 5, 15 plus 5, 20. So it's a series of 5-year bonds. And my investment that way will have a time horizon of 20 years. Or you can ask me, Dr. B, would you like to invest here at time zero in a bond where you will pay some money at this point, and then it will mature right at the end of your investment time horizon. So this is one shot, 20 years investment. So this is long term. And this is a series, as you can see, of, well, since this is a 5-year time period, let's just call it a series of medium terms. One medium term, second medium term, third medium term, fourth medium term. So if you ask me, Dr. B, you have two choices, right? So this series, the one that you see here, this one, this one, this one, this one, a combination of this is my cup of tea. And this one short investment is my cup of coffee. If you ask me and I say, it doesn't matter how you invest my money, just invest it today straight away for a period of 20 years so that after that, whatever return I will get will be, and if I think that the return will be the same as what I will get in this way, if I go a piecemeal way, like 5 years first, then the next 5 years, then the next 5 years, the next 5 years, then a series of these investments will also give me the same return as a one single investment would do. Then I would say that I'm indifferent between the two investment choices, and that is what is the assumption on which the pure expectations theory is based. Right, so that's basically that's what it implies. Perfect substitutes is the implication is that the expected return from bonds of different maturities at the end is going to be equal, so that you have nothing to choose between. Now, at this point, if there is somebody who likes to go into the math of it, I would actually create these two strategies. So, how much will be the return in a single investment of 20 years? And how much will be the return? How will we calculate the return, which is broken into four parts, four steps, one, two, three, four, right? So 20 years again here. So we will make computations for this part, we will make computations for this part, and we will realize that towards the end, the return, eventual return would be the same if you reach the destination via this path or if you reach the destination via this path. So once we make that calculation and give it a notational framework, that would become the underlying math of it. Right, so if you're interested, you can watch my video on my channel. At this point, what we are concerned with is basically that pure expectations theory, in making the assumption it does that bonds of different maturities are perfect substitutes, it eventually arrives at the conclusion. So this is that conclusion here, the destination. In the end, what we realize out of this theory, first we will write it in simple English, then we will convert it into an equation, and then we will convert that equation into a formula which can be easily remembered. So the conclusion is this, that long-term yield, or let's call it rate, because we are using them synonymously, is equal to, or is an average of short-term yields. rates, right? So this is what is the conclusion. So we can write it here. To to write it in equation format, let's make a simplifying assumption. Let us assume, and this assumption is just to save time and space, nothing else. Let's define. I'm writing L for long, T for term. I'm restricting my long term to 2 years so that we don't have to write too much because we need to just understand the message. And let us define short term, S for short, T for term as 1 year. So language mistake, 1 year, not years. So given this assumption, we can use this understanding, this conclusion, and write an equation about it. We can say since long term is 2 years, so the 2 year interest rate or 2 year yield, 2 year yield or year or rate, whatever, will be equal to, what does it say? An average of short-term yields. So since 1 year is the short term that we have defined, in a period of in a total time horizon of two years, let's visualize this. 0 and 2. During this whole time horizon, you can have two short terms. Isn't that so? This is one short term period, and this is another short term period. And together they comprise one long term, right? So what the sentence or the conclusion is saying is that the long-term rate here, the rate for this entire length of time is going to be simply an average of what the rate is here between this time and what the rate is here between this time and this time. So there's a rate of maybe there's a yield called X% here, and maybe there's if you invest here at this point in time, then from here to here the yield is maybe Y%. So the conclusion simply is that the 2 year rate would be equal to X plus Y divided by 2, as simple as that. So, but we need to write the definition of X and Y, so that will be a little lengthier. So let's write that. X is what? X is the 1 year rate now, because it's starting at time 0. So that's why now. Plus, what is Y equal to? Y is is a rate that begins at time 1 and ends at time 2. So this whole length of time, right? So this means, and this whole length of time is what? Equal to how much? That's also equal to 1 year, but it does not start till 1 year later. So we will write here 1 year rate again. No problem with that. 1 year rate, 1 year from now. That's the definition of Y. And because there are two items that we are adding up and we want to take an average, you know what to do. You will simply divide the sum by the number of items too. So that is what is the conclusion of the pure expectations theory. What we will do is, as we proceed further in the chapter, we want to remain consistent with your textbook. So therefore, instead of every time writing this as a 2 year rate and every time writing this and use so many words like 1 year rate now and 1 year rate 1 year from now and so on, we will curb this, we will shorten it by using notations, where notation simply means giving short names to long things. So instead of writing 2 year rate, we will just write I for interest rate, and in the subscript we will write 2 because it's a 2 year rate, and then we will write a T to signify time, I 2T. And then on the right hand side, we are writing what is the definition of X, 1 year rate now. So we say this is the interest rate I, because it prevails now, we call it prevailing at time T, IT, right? And then what's the definition of Y? In defining Y, ladies and gentlemen, I'm using red ink to indicate something important. Always assume that you're standing here on the timeline at time 0. Standing here, let's just neatly draw it one more time. Standing here at time 0, and this is time 1 and this is time 2. You are standing here. and looking on to the future. This is how your vision is going. So when you are standing here at time zero, looking on, this period is now, and this period is 1 year later, and this period is 2 years later. You will realize that I've by default assumed that the length of a period is a year. That's why I'm continuously referring to it as 1 year later or 2 years later. But more generically, it would be 1 period later or 2 periods later. So we are making the analysis at this point in time. At no other point in time, you can make an analysis. If you think carefully, you will realize that you as a person exist only here. And unless you exist, you cannot analyze anything. Isn't that so? So the only place where you can analyze something is in the present moment, which is now. You cannot analyze if you're here in the present moment, you're not here as yet. So you can't analyze here and you can't analyze here. So the only place you can make an analysis or talk about something is the present moment. So from the present moment, looking on into the future, we are talking about the future. So at the moment, we say that the interest rate here, let's change color to blue. We say interest rate here at time zero is IT, right? And it is here and it is going to be applicable for this whole length of time, this whole length of time. That's our X, right? And that's our IT. And then when this time period arrives, at this point in time, we don't know what the interest rate is going to be. We can only expect, right? So for this period, this length of time, which is Y, we can only have an expectation, right? Because at this point in time, zero, we know for certain. So IT is known with certainty. But if somebody asks you, hey, look, Dr. B, what do you think the interest rate will be after 1 year if I have to make a 1 year investment later on? Then Dr. B will start scratching his head and say, boy, looks like I look at the history and there's a trend and the interest rates or the yields have been moving this way. So I hope or I expect that come this point, when you reach here and you're ready to invest your money for 1 year's duration or 1 year's time, and that is this length of time, then at that time we expect that interest rate is going to be at this time t plus 1. Because it's expected, we will write it as i.e. t plus 1. So this i.e. t plus 1 is what prevails, is likely to prevail in this segment of the timeline, right? So this is what we will copy and paste and put it into the formula. So we'll pick this thing from here and take it in the formula here. And there are two items, so therefore divided by 2. Right? So this becomes the pure expectations formula. So let's label them again. This is long-term rate. This is short-term rate now. And this is also a short-term rate, which is expected to prevail at a later time. Any questions, ladies and gents, up until this point? No questions. Good. All right, so what you're seeing here is a perfectly valid formula that reflects the idea of pure expectations theory, right? But this is limited now only to a 2-year case. If we had to make a generalization and a general formula, let's write that with a different ink so that it stands out separately. Let's do it with blue. Instead of 2, let's make it for n periods long, is equal to what we will write. The first item, the interest rate which prevails now, the short-term rate, plus the interest rate we think is going to prevail in the next period, I expected t plus 1 period. Then the interest rate that we expect to prevail 2 periods later or 2 years later, like that. And like that, this series will go on till now. You will realize one thing, you need to be careful. I'm just going to write here t plus, and then I'm going to leave it like this because I want to complete the fraction first. There will be n number of items on the numerator, so we will divide by n. There's no problem with that. But here, I should not write t plus n. Why? Because do realize this, that when it is the second term, we write what digit here? 1. When this is the third term, we write the digit 2. If we wrote another term here, i.e., this is the fourth term in the series, then we would say t plus 3, and so on. So every time, whatever is the number of the term, we write a digit which is one smaller than that. So instead of writing n for the nth term, we will write an n plus n minus 1, sorry, n minus 1. So that is something that you need to be careful of. If you have not understood it, you will please ask me. Is everyone okay with this, ladies and gentlemen? Please give me an indication that you are all here with me. I mean, I'm not just speaking like a madman in a room alone. Tell me that I have company. Do I have some
Yes, sir, we
company?
understand you.
Okay, all right.
Quick question.
Thank you.
So
Okay, so let's see how this pure expectations theory is successful in explaining. We said earlier 67% of the
So I think someone had a question.
uh, did
Yes, sir.
somebody? Yeah.
About the E, right? The E just simply means the expected, yeah, but it does not
Yes.
really affect the value in any other way.
No, if I say, for example, Mikhail, that I expect that the interest rate next year will be 5%. So it's just an expectation. Whether it will
Okay.
be 5% or not, that we will find out only next year. But today, if we are making an analysis, we will work with the 5% number.
Okay.
Yeah.
Thanks.
So we said that pure expectations theory, which is encapsulated now in this formula here, is successful in explaining 67% of the term structure. So how does it do that? What is the first term structure fact? Ladies and gents, anybody recalls that? Somebody can pick up the mic and tell me what is fact 1?
Fact 1 is that the interest rates for different maturities move together, so they're basically simultaneous.
That's so correct, Modest. Thank you so much. Interest rates for different maturities tend to move together. You can very well see here that this is the long-term rate. Let's just highlight this. This is the long-term rate. Long-term. And this whole thing is a series of short terms. This is short term, short term, short term, short term. So you can very easily see visually through the formula itself that long-term rate it doesn't exist on its own or independently. It is actually a result of a computation, and the computation is that we have added up all the various short-term rates and divided by the number of items. So long-term rate cannot have an independent existence. It will have to move in tandem with whichever direction the short-term rates are moving. So there is no independent movement of the short-term yield or the short-term rate. So if this average is going up, if this average is moving up, then obviously the long rate will also go upwards. And if this average is going down, then this long term, which is the result basically, is also going to go down. So the first fact is explained that way because long-term rates and short-term rates are connected via an average. Therefore, they have no other way but to move together. Do we understand this?
Could you go over that part one more time, please?
Okay, let's take an example. Interest rates on of different maturities move together. So let us say, um, let us say, let's say there's a bond which is going to mature in 4 years. So bond A has a 4 years runtime, and let's also do something. Let's call it. Let's call it bond B, and make it 1 year. It's going to mature in 1 year's time. So the 1 year rate, which is the rate now, is called IT. And let's say that it is equal to, let's just make up something, 2% per annum. Then, in order to find out what will be the rate or the yield given to us by a 4 year bond, now this is going to be longer than 1 year. So in our assumed scenario, this is long term. So what we need to find is the interest rate on the 4 year bond, 40, right? Because I don't want you to confuse between certain items. For example, if we draw a timeline while we are discussing this, let's just clarify this one time. So at this point in time, so this is time 0, 1, 2, 3, and 4. So when I write here I4T, I mean a long-term rate, which means that I'm standing here on the timeline and I'm looking at a one-shot investment, which I will make here, and it's going to mature at the end of 4 periods. This is, and what yield I will earn on this one single shot investment, that is I4T, long term, right? Whereas this is the interest rate which prevails for 1 year during this time span is IT. The interest rate which prevails for another short term during only this is also a 1 year rate, but it will prevail 1 year later. This is T plus 1. This is also going to be a 1 year rate here, but it will be applicable between this time and this time. So this is this. This is also going to be a 1 year rate, but it will be applicable during this time. And if we had one more period, by the way, and there was another short-term interest rate which prevailed during this time, between time 4 and time 5, then this would also be a short-term rate, but it will be written as this. So you have basically then two similar looking items, which I don't want you to confuse between. See, there is an IET plus 4, and then there is an I4T. These are not the same things. I hope you understand the difference. Whenever we write it like this, it's always a long-term rate. And whenever we write something with an expectation and a denominator and a subscript like this, even though the digit is 4 here, this is a short-term rate, and it tells you that this is going to be a 1 year rate, which will be applicable when 4 years are done and we are moving towards the 5th year. So between years 4 and 5, this 1 year rate is going to be called IET plus 4. Whereas if we stand here on the timeline at time 0, and consider an investment which will run from time 0 directly to time 4, and there's no stoppage in between, then it is a long-term rate or I4T. There is no expectation about it, as you can imagine, because you're standing here at time 0 now. You know what the rate is today. Since you already know what the 4 year rate is today, there is no E here. There's no sense of writing an E. Why write an E? Why think about an expectation when you already know something with certainty, right? So there is no E about this item here. So please keep this distinction carefully in your mind. So back to the main business. So there's a 4 year bond and there's a 1 year bond, bond B. So at the moment, the interest rate is 2%, which corresponds to this on the timeline. What we want to find out is that if I invest not for this duration of time, that this is not what I'm interested in. This is not what I'm interested in. I'm interested in this whole thing, whole period in one go. So if I have to do that, then what would be the interest rate? I4T will be equal to what? Now, since this is long term, this must be an average of the short term rates, right? So it has no independent existence. We can't know this unless we know the short term rates. It will depend on what the short rates are, right? So let us say this is 2%, and then this is, let's just make up something. Let's keep it simple, 3%. The year after that, T plus 2 is, let's just say 4%. And the year after that, let's just say this IET plus 3 is 5%, right? So what will be I4T? It will depend on these values. Since it will depend on these values, we will say that it will move according to what these values are. So both this and these will move together. You can see that 2 plus 3 plus 4 plus 5 divided by how many? 1, 2, 3, 4, right? So this is equal to what? 3 into 5 and 4, 9 and 5, 14. 14 divided by 4 would be 3 point something, right? 3 point something percent, right? So I4T is 3 point something here. But then is it independent? Is it really not related to what happens here? This is not true. For example, if I were to change this now to say 3%, 1%, 2%, and another 1% here, then what would be I4T? It has no independent footing on its own. It can't say that I will stay 3 point something. I will have to respond to what happens to the short term rates. So this time I'm going to have to change to this. So I will have to move together with the short term. 3 plus 1, 4, and 2, 6, and 1, 7 over 4. Right? So it will be close to 2%, so 1.8 or something percent. Right? So it has changed from 3 to 1.8 in response to a change in the short-term interest rates. So long-term is moving together with the short-term. Do I make my point clear? As somebody had asked this question. Have you gotten your answer? Okay, right, Mikhail. So fact one, this is basically fact one, that they move together. So that is explained. So let's just keeping a record of that. Fact one is explained. What about fact two? What was fact two? Anybody remembers? Anybody remembers fact two? Without reading your notes, can you recollect? What's fact two? Ladies and gentlemen, fact two was that yield curves have a typically upward slope when the short-term rates are low and a downward slope when the short-term rates are high. In doing what we have been doing just now, we have already kind of seen it, maybe not that obviously, but let's reconstruct again something. So let me go back to a different color. Let's assume 3 years rates. Let us say our rates are IT, which is the rate now, 1 year rate now, is equal to 3%. Next year, we are expecting that the 1 year rate is going to be 4%. The year after that, which is 2 years from now, actually, we are expecting that the interest rate will be 5%. So what can we conclude about the 3 year rate? On the basis of these three values, we can calculate a long-term rate called I3T, which will be 3 plus 4 plus 5 over 3, which will be what? 4 and 3, 7 plus 5, 12 divided by 3, 4%. If this is what is the scenario, visualize this on a yield curve. This is the short-term rate, ladies and gentlemen. This is the short-term rate. See my tick mark here, which corresponds to this. And this is my long-term rate, which is nothing but an average of these three. So they are moving together, all right. That's fact one. That's old story now. What does the second fact tell you? When the short rate is lower and which means that the long-term rate is going to be comparatively higher. So the 1 year rate now is, let's say, 3%. And if you invest for 3 years, so this is 1 year, 2 years, 3 years. If you invest directly for 3 years, you will get what? This 4%. So here, if it is 3%, investing now for 1 year gives you 3%. Investing now for 3 years will give you 4%. If you connect the dots, what kind of curve do you see? Upward sloping. That is the first part of the second empirical fact, that when short-term rates are lower, then we will see an upward sloping yield curve. Let's reverse this situation and change the color and rewrite this again and see that if, let's reverse the order. I wrote it here 3%, 4%, 5%. Let's reverse 5%, then 4%, then 3%, right? On the basis of this, you will observe that there is nothing that will change about the long-term rate. If I write I3T, it will be an average of these three numbers again, 5 plus 4 plus 3 divided by 3. So that gives me what? 5 plus 4, 9, and 3, 12 again, divided by 3 gives me 4%, right? So the same long-term rate. So this is my long-term now. And this, where I'm doing the check mark here, is the short-term rate, which corresponds to this. So if I do it visually, then you'll see this is time 1, this is time 2, this is time 3. If you invest for 1 year, what you're going to get, you're standing here on the timeline at time 0, right? And if you invest for a period of 1 year now, you'll get what? About, let's say, this is 5%. This is what you will get. But if you're standing here again at this point and think about not investing for 1 year, you're investing to you're thinking of investing straight away in something that matures at this point in time, time 3, then that investment is going to give you what? This is the 3 year rate is equal to 4%. So let's say if this is 4 and you plot it here, then as you can see, the yield curve is what? Downward sloping. So that confirms the second part of the second fact, which said that a downward slope when short-term rates are high. The short-term rate of 5% is higher as compared to the long-term rate, which is 4. So therefore, we see a downward sloping curve. The only thing which pure expectations cannot explain is that there is no telling, there is no way to be sure whether in the time to come, this is the situation that will prevail, that the rates will continue to rise. And there is no telling, and there's no certainty or guarantee that this situation will prevail, that the rates will continue to fall, go down, 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 because both have equal likelihoods. How is one to tell which situation will prevail? Will we see a rising trend like 3, 4, 5, or will we see a falling trend like 5, 4, 3? Different people will have different opinions about it, and nobody in particular can be right or wrong, right? Everybody has a different set of information, different way of thinking, different way of interpreting that information. And according to multiple interpretations, there can be, somebody can say, okay, this will not be as neat as 3, 4, 5 in a sequence, or it will not be again as neat as, if as neat a sequence like this 5, 4, 3, maybe it will be something mixed like 2.5 and then 4.3 and then maybe 1.8. Who is to tell? There's no guarantee that a particular pattern is going to manifest for sure or not. So that is why the third fact of the term structure, which says that yield curves are typically upward sloping, that cannot be said with confidence, right? So though we have said that the yield curves will be upward sloping in a certain situation like this one here, but who is to say that this is the situation that will be there with certainty or most of the time? There is no way to say that under the pure expectations theory framework, because the other possibility also is equally valid, that the rates may start falling. So 67% of what the third term structure says is confirmed by the pure expectations theory. On the basis of this, ladies and gentlemen, we will pick up an end of chapter problem, and we will look at the problem, and then we will set up a solution. And then I will give you some homework based on this problem. You should try to attempt it if you feel interested. This is depending on which edition you have picked up for your purpose. The problem number may change, but in the book that I'm using, it's problem 14. So it may be problem 14 at the end of your book, or it may not be. You can just verify, but the data are the same. What the problem tells us is that the 1-year rate is this. So let's look at the data, and then I'll explain the logic and the solution for this. It says the 1-year rate is equal to 5% at the moment. They also tell us that the 2-year rate is equal to 6%. And they also tell us that 1-year rate 1 year from now is equal to 7.25%. This is the information that they have given us. And the question is, I'll just read it out for you. Listen carefully. How can you take advantage of these rates to earn a risk-less profit? So we have to find a risk-less profit or a risk-free profit by taking advantage of these interest rates. So we'll have to first of all see whether a risk-free profit possibility exists or not, and then calculate it. And they continue to say that in solving this problem, assume that pure expectation theory of interest rates holds. So if the world was described completely by pure expectations theory, then would it be possible for you to use the interest rates that you see now to make a risk-free profit? Ladies and gentlemen, risk-free, there is no such thing as risk-free profit unless and until you are able to earn something called arbitrage profit. This is a term which is not introduced to you in your textbook. I am giving it to you. Please take a note of this. Arbitrage profit is the only type of profit which comes risk-free, right? So the question becomes, what is the meaning of this arbitrage? It's very simple. It's a good-looking term for something which is very simple, and that is when you try to exploit mispricing in the market. Again, this might confuse you a little bit. We will simplify step by step. Exploit mispricing. Exploiting mispricing means whenever you find that the law of one price is violated. So still more confusion. The law of one price is violated. So then what is law of one price? Law of one price states this, that same commodity, the same product should have the same value no matter where it is traded in the world. Right? So if an apple trades for $3 a piece in Trinidad and Tobago, there should be no reason why it should trade for $5 in Jamaica. Same apple, right? So if a Toyota car sells for a certain price in Japan, there should be no reason why it should sell for a different price in Trinidad and Tobago. That is law of one price, which often is violated because we introduce a lot of market imperfections. Now, from Japan, it will cost you to bring the car over here. Transportation costs will be there, import duties will be there, other kind of taxes will be there, right? So the cost of Toyota vehicle will jump up in Trinidad and Tobago as compared to what it sells for in Japan. So that way you can say that the law of one price is going to be violated. But if you take away these market imperfections, then intrinsically speaking, its actual core price should be the same, right? So if we say that Toyota sells for X dollars in Japan, it should sell for X plus taxes and duties and other stuff plus transport in TNT. So if you take this out of the picture for a moment, the core price or the core value of the product should still remain X. And if this core value remains X across various territories and places, then law of one price holds, right? It's not violated. It's only if this car sells in Japan for X dollars and here it sells for X plus one, and then taxes and duties, then there is a difference because the core price has changed. Then it will be advantageous for you to buy the car from where it is cheap and sell it off where it is expensive. Say I'm going to place a buy order here because it's one point lesser here, and I'm going to place a sell order for the same car here because it fetches me an extra point in price, right? So that is when law of one price is violated and there is mispricing, which you are now exploiting. Well, how? By buying it at a place where it's cheap and selling it where it is expensive. And the difference between this sell and buy price is your arbitrage profit. And you have simply used the price differential to make a profit. You have not taken any risk. Therefore, it is risk free. Right. So I hope you understand the whole sequence of what is risk free profit and how you can obtain that by mispricing, by exploiting the mispricing. So back to the substantive part of the question, we see if you consider interest rates also as price of money, you can see these as prices for money. For um, investing for one year, you get 5%. That's the price paid to you. If you invest for two years, let's say I'm using the word invest. Let us say you lend money to somebody for 1 year, they will pay you a price of 5%. Let's say you lend your money to somebody for 2 years, they will give you a price of 6%. Let's say you promise that you will lend somebody some money after 1 year for 1 year, then the price that they will pay you is 7.25%. So are these prices in line with each other or are they aligned with each other or not? That is what we need to check to find out whether there is going to be a possibility to make any risk-free profit or arbitrage profit or not. If these interest rates or these prices are well aligned with each other, then there will be no profit opportunity. If they are out of line or out of sync, then there will be a profit opportunity. So the first thing that we will need to do is to check whether they are in sync or not. So just to keep this data visible and continue in the same place so that you can relate the solution to the problem, I'm going to erase this part because this was just a conceptual thing. So just give me a few moments till this eraser works through slowly across the page. Almost there. All right. So let's get back our pen. So the question says, assume that you live in a world which is described by pure expectations. So in a pure expectation framework, let's label these. This is 1 year rate, so this is IT. This is a 2 year rate, so this is I2T. This is a 1 year rate expected to prevail 1 year from now. So this is I expected 1 year from now. So T plus 1, right? So we have given these the desired labels, and out of these labels, we can immediately see that this is the only item which looks like a long-term rate. So let us calculate our long-term rate based on pure expectations theory. Pure expectations theory says that long-term rate, like I2T, should be an average of the short-term rates. There are two short-term rates here. One is this, and one is this. So let's calculate their average. 5 plus 7.25 divided by 2. So this is going to give us 12.25 divided by 2. And so this is going to be what? 6.125%, right? This is what the rate should be in the world which is described by pure expectations theory. So this is should be. But what should be may not be equal to what actually is. What actually is this. I2T in the market, if you see it published in the newspaper, you find that it is actually equal to 6%. Whereas on your desk sitting here this morning, you have calculated that it should be 6.125%. So there's a discrepancy. This means that something is not right, that these rates are out of alignment or out of sync, and therefore there is a profit-making opportunity. Ladies and gentlemen, if you were computing something like this, and if you used this formula here, and you went on with the calculation and your result here was 6%, then you would conclude the problem by saying that since the theoretical rate is equal to the observed rate, there is no profit-making opportunity, because this is the theoretical rate as proposed by the theory of pure expectations. If the theoretical rate is equal to the observed rate in the market, then there is no profit-making opportunity, and that is the end of the story. But in this case, there is a difference. Now let's see how we exploit this difference. So what we observe that the actual rate or the observed rate is lower than what it should be. Right? So actual rate is 6%, which is lower than 6.125%. So when the rates are lower as compared to what they should be, and if I gave you a question to ponder upon, and the question was that if the rate was actually lower than what it should have been, then what will you be motivated to do? Will you be motivated to borrow at that lower rate, or would you be motivated to invest or lend at that lower rate? I think everybody here in the audience today will give me a unanimous answer that when the rates are lower, that serves as a motivation to borrow, not lend, because who will want to lend at a lower rate than what it should be? But if the rate is lower, then there is an incentive to borrow because the borrowing can be cheaper. So let's just make that decision ourselves. What we can do is let's just begin with some assumed amount. Let us say we have, or we don't have, let's just say let's borrow, because that's what our conclusion is, because the rates are lower than what they should have been. So let us borrow. And let's make an assumed amount, say $1 million, if somebody is willing to give us that, at the lower rate, which is this 6%. And this 6% rate is applicable to what? Go back here up 2 years. So let's take a 2-year loan basically at a 6% rate. Let's borrow 1 million at 6% for 2 years. Right? So that we don't forget, let us make a remark here. Let me just erase this and write it as a remark and call it 1A. That after 2 years, we will owe an amount because we'll have to repay the loan amount owed. Because sometimes when we usually carry on with the computations, it's possible that we will forget to repay. Yeah. When we have to collect money from somebody, we don't forget. But when it is that we owe somebody, it's very convenient to forget. Amount owed after 2 years. Let's calculate this and write it. So on your financial calculators, you should be able to do that because today you are taking a loan of 1 million. So $1 million coming in to your pocket. You are taking the loan for 2 years at an interest rate of 6%, right? So there's no other payment in between, so you can compute future value. That is the amount we will owe. So if you will do this, and you can check this on your calculators, whether your result is the same as this, it should be equal to 1,123,600. So if you have the calculator handy, just run this calculation there and check. If there is something different, inform me so that we can make a change. So the situation as it stands now is that we have taken a $1 million loan for 2 years, and we know that after 2 years, we will be repaying the loan with interest, and the repayment amount will have to be this. But it is still 2 years to go for this to happen. What to do now with the $1 million that we have? Let's put the dollars to use. For now, let's say invest the $1 million that you have borrowed. So $1 million. What are the opportunities available? Let's go back up and see. Let's go back up and see. So we have an opportunity here. At the moment, this rate is available, 1 year rate. So let's invest for 1 year at the moment and lock in this rate of 5%, right? So invest $1 million at the rate of 5% for 1 year, which means that after 1 year, when the investment matures, how much will we receive from our investment? We will receive, we can again calculate, we are investing how much money leaving our pocket, 1 million. How long is it leaving for? 1 year. At what rate? 5%. So after 1 year, how much will we receive? So if you will calculate this, you should get dollars 1,050,000. If you have the calculator in your hand, just run it and confirm the numbers. If it is different from what you see, from what I'm doing, then let me know. So this is our situation after 1 year. So let's track our position here. Let's just do a little timeline. At time zero, what did we do? At time zero, we borrowed 1 million. So 1 million came in. And at the same time, we invested 1 million. 1 million went out. After 1 year, this is time one, $1,050,000 will come in plus. And if this is time two, we know that at time two, there's an amount that we need to pay. So $1,123,600 have to be paid out, right? And we are now here on the timeline. Let's just mark it here. We are now here on the timeline. And there is still this whole year to go. And we have this amount sitting with us. So should we hide it under the mattress, or should we still put it to use for another year? We should put it to use for another year. So that's what we are going to do in step 4. Because 1 year late, when we were here on the timeline, this is where we were standing at time zero. Then we knew that the rate available to us for investment is 5% for 1 year, for this whole length of time. And we also knew that we are expecting that when we reach here, when we reach here on the timeline, then the rate for this time duration or this length of time is likely to be what? Let's just check. Likely to be IE T plus 1 equals 7.25%. So if that is what we are able to get, we should be mighty happy about it. So since at this point in time, $1,050,000 are sitting in our pocket, if we are able to invest them at a 7.25% rate, which is applicable during this length of time, then we should be happy. Invest $1,050,000 for another year at a rate of 7.25%. If it materializes, that is. Then your computation would be, now this will become your present value. So PV, money leaving out. So here you can write money came in and then it went out because you reinvested it here. So minus 1,050,000, reinvest for one more year at a rate of 7.25%. And if you calculate the future value, you should get something like, and please check on your calculators, we should all be on the same page. 1,126,125 is what you will get after at the end of the second year, right? So this is what you'll get here, because this is invested at this point in time. Here it will mature, so there will be an incoming of 1,126,125. Incoming, right? This is incoming, and this is outgoing. You see that the outgoing amount is less than the incoming amount, so there is a profit for doing actually nothing. So you can say arbitrage profit, or if you want to remain consistent with your book, you can say risk less profit is equal to, this is the maturity value of your investment, finally 1,126,125. And from this, you will subtract the loan amount which is due, which was 1,123,600. And the difference is $2,525. That is your risk-free profit for absolutely doing nothing, just playing the interest rates. Fine. Ladies and gentlemen, let me just zoom this out if possible and put the whole sequence on display so that if there is a question that you need to ask, you can. These are the 5 steps we took. You can review the steps for a few moments. If there is a question that pops up, you think you didn't understand something, you can ask me. Then I will give you the homework, a similar question for you to do, but with an opposite scenario. You should try doing that and see if you can get a risk-free profit. If not, discuss with your tutor, or maybe when we meet next time, you can talk to me about it. Good, so let's zoom back in. And this is your homework. Let me put that in a different color so that so I'm saying I'm not just using the whole thing, I'm just now using notations. IT is 5%, that's the 1-year rate now. And I'm saying that the 2-year rate at this point in time is given as 6.5%. And I'm also saying that we are expecting that 1 year later, the 1-year rate is going to be equal to 6%. So examine these rates, assuming pure expectations theory holds. Can there be a risk-free profit? If yes, then calculate the profit. Right? Try it at your home, discuss amongst yourself, and see what will be the possibility. If you're successful in doing it, well, congratulations in advance. Most likely you should be if you apply enough mind and time to it. If not, then you can either talk to Ramzan or you can talk to me. Right, at this point in time, let's proceed forward and let's talk about the second theory, term structure theory, which is the market segmentation. As I told you, the remaining two theories don't take much time. Market segmentation theory, just like pure expectations theory, is based again on an assumption. And this time, the assumption is the polar opposite of what we had seen before. In the case of pure expectations theory, it says that bonds with different maturities are not so notice that I've written this in capital letters because we are emphasizing this, not substitutes. And again, for emphasis, at all. Right? So if there are two bonds which have different maturities, bond A maturing in 5 years, bond B maturing in 20 years from now, they live on different islands. They live in totally separate watertight compartments. They never meet in life again. They never see eye to eye. They have got nothing to do with each other, right? That is the assumption. So basically, then this means that they are going to be priced completely differently. Their pricing mechanisms are going to be different. Their yield generation is going to be different, and it is one of them will have nothing to do with the other one at all. So if these bonds live on separate islands and they are not connected at all, so there is nothing like in pure expectation, there was an average which was establishing a connection between the long term and short term. That has gone away. No such thing. So if they are totally isolated and there is no integration whatsoever between the long term and short term, then fact one, that interest rates on different maturities move together cannot be explained because there is no connection. So how can they move together? As simple as that. We also had demonstrated through an example that when short rates were low, the yield curves would be upward sloping. And when short rates were high, the yield curves would be downward sloping. That was fact number two. And we could demonstrate that because we were still calculating averages. If we scroll back up, you'll be able to see. Here, see? This was an upward sloping example, and this was a downward sloping example. But in these examples, we had assumed this as short term, and then we had calculated a long term based on an average. So, and if we said that if this short term number was lower than the long term number, then the result would be an upward sloping curve like this. But now, since the average or any other such similar mechanism is broken down in the world described by market segmentation, the markets are completely segmented and isolated, then there is no connecting link between the short and the long term. And therefore, fact two also cannot be explained because of a lack of connection between the two extremes. What is fact three? Fact three said that yield curves are generally or typically upward sloping. And to understand this, we'll just have to go into the minds of the investors a little bit and understand their psychology. One possible reason could be that if I, for example, were to ask you today, this is you, and I'm asking you, would you like to invest your money in a bond which is going to mature in from now, let us say in 2 years from now, or let's say 1 year from now. versus a bond that's going to mature in 30 years from now. And I ask you that without using any logic, without thinking about it, without using any reasoning, simply on the basis of your reflex or a gut feeling, immediate feeling, which investment will you go with as a reflex action? If not all, many of you will want to gravitate towards this side 1 year. I mean, later on you can apply logics and you can apply reasonings and you can think who is issuing the bond and how reliable they are and how much default risk they have. Are they issued by the government or they issued by reputed companies? This and this not. That is something valid, but that comes later. My question was that as a lay investor who is not a finance pro like you all, then what will they generally think? What will be the general feeling? That short term is clearly visible, and something which is visible is it gives you more certainty, more safety. 30 years is way beyond the horizon. You can't just see or you can't clearly visualize what's going to happen in 30 years. Maybe you yourself will not be there to see the maturity date. Maybe the company would get defunct by that time. Who knows? Maybe the governments will change, or maybe you will change your location and you may not be interested, or you may forget, or somebody might steal, or something may happen, right? So anything or something can happen during this long, long period of time, long term. So this gives you more certainty as a lay investor. Most of the investors are lay investors, by the way. Not everybody is an expert like you. And this is more uncertain. And since we had established this psychology earlier also that you are in the debt market or credit market or bond market here for safety purposes more than return purposes, something that provides you or seems to provide you with more certainty is the preferred way. So if this is what is preferred, the demand for these bonds will go up. Relatively speaking, the demand for these bonds will go down. If the demand for these bonds, 1 year bonds, will go up, the price for these bonds will go up. And the price relatively for these bonds, long-term ones, will go down. And because price and yield have an inverse relationship, the yield here will come down. And the yield here will go up. You can now imagine or visualize the scenario. This is the short-term yield. This is the long-term yield. Short term is lower, long term is higher. So on a time yield space, if you connect a lower yield in the short term with a higher yield in the long term, what do you get? You get an upward slope. That is why, because of this investor psychology, you have a generally upward sloping yield curve. That's what is the conclusion of market segmentation theory. So market segmentation theory through investor psychology and that argument is successfully explaining fact 3, which is 33% of the term structure. Don't worry about any calculations here, there are none, which takes us into the third theory, which is the liquidity premium theory, which, as you know, is going to be nothing new. It's going to be a combination. And it tries to meet the two theories halfway, and which will be clear to you if you look at the assumption of the theory, which says that bonds of different maturities are substitutes, but not perfect substitutes of each other. That's the key difference. They are substitutes, but not perfect substitutes of each other. So, for example, If you will ask me, what would you like to have, Dr. B, a cup of tea or a cup of coffee? And if I say, if you're offering a cup of tea, I would like a little cookie with it, please. But if it's just coffee, then just the cup of coffee alone is fine, right? So you see that I'm okay with both, but with the cup of tea, I think I'll need a little cookie as well, right? So something extra is needed to make up for something which is not there in the coffee. So they are substitute, but not perfect. Something extra will be needed to fill in the gap. So what this theory does is that it says, okay, bonds are substitutes. Therefore, we can use the average mechanism used by the pure expectations theory. We will borrow that. But since they are not perfect substitutes, we will say that, well, pure expectation tells you this. If you recall, this is the generic conclusion of pure expectation. So the liquidity premium theory is saying, okay, we have no problem with this. But this is then just a cup of tea. This average is just a cup of tea. And to make it equivalent to a cup of coffee, we will need something extra. And I'm writing that extra part by writing a plus sign here and adding something to this. And I'm saying that this something is denoted by the letter L. And I'm going to write in the subscript NT. The letter L stands for liquidity premium. Where did it come from and what does it mean? We'll talk about this momentarily. So look at the return to the market segmentation scenario. What we were observing, there were red flags all over the 30-year thing. Uncertain, therefore no demand. So sad face, no demand. Prices going down, horrible, hair standing up, right? So what does the company have to do to sell off a long-term instrument? Do you have to add a sweetener, add something, give something extra, which these bonds are not offering. Add something extra, that extra is the premium. But why are we calling this the liquidity premium? Because see, there is no demand for this bond. If nobody wants it, then it doesn't trade. No trade. No trade means no liquidity, right? No liquidity means that if you are somehow able to convince me today and push this bond down my throat, then later on I'm going to find myself in the hot soup where I have the bond, but I cannot sell it off to anyone else because nobody else wants it. So nobody is ready to trade with me. And if they're not ready to trade with me, I just have this useless piece of paper with me and I can't convert it back to cash, no liquidity. And I come back. And this is the fear I'm narrating to you as a company. And you're saying, okay, Dr. B, if you're so scared about that tomorrow, if you buy this bond from us today, tomorrow you will not be able to liquidate it conveniently. For that inconvenience, we will give you a little add-on here, a little extra 2%, 3%, whatever, right? So this little extra 2%, 3% premium, which comes due to the lack of liquidity, which lack of liquidity happens because nobody ready to trade. Nobody ready to trade. Why? Because there is hardly any demand. Why there is no demand? Because long term is very uncertain. Short term is comparatively more certain. That's the whole chain of thought. So in order to compensate for that inconvenience of lack of liquidity, this liquidity premium is added on. So this comes from pure expectations. Pure expectations. This is a byproduct of market segmentation theory. A combination of the two gives us the final result here, the long-term rate or the long-term yield. Ladies and gentlemen, we have about 12, 13 minutes left for the scheduled close. Would you like to do another numerical example, or would you rather want to do it with your tutor? If it is that you wish to leave a little early, I can let you go now. Or if it is that you want to spend a little 10 more minutes, then we can do another example. The choice is yours. You can let me know. Mikhail, you want to do one more? Anyone else? Or is it Mikhail, the lone warrior there?
Yes, do another one now.
Okay, Sachin. Okay, Nirwan, Jonathan. All right, so let's to do this example, what we need to do is we need to understand one little concept. And here that is. What we are going to do in the example is that we are going to try and forecast. Because earlier also, Mikhail and I think Modest also, I think, had asked the significance of this letter E, expected. So whenever there is an expectation, we know that there is something uncertain about it. That's why we are expecting this may happen, this may not happen, something like this. So it's good if there was some kind of a forecast available for what might happen. Forecast. So what we want to do is we want to forecast short-term rates. Which whatever rates we are writing like this. T plus one, T plus two. If you are writing like this, long term, they need no forecasting because they are known right now, today. So if you're forecasting short-term rates, let's just write a simple forecast formula for forecasting this IET plus one. And we will follow the same general template for all other things as well. This is what you should do. You should write a numerator in which you should write 1 plus the interest rate or the yield for 2t, and raise this to the power of 2. And then you should write a denominator. Sorry, let me complete this for you. Otherwise, you'll later get confused. You add I2t to it and subtract the liquidity premium L for 2 periods from it, and then raise it to the second power. Then on the denominator, you write 1 plus I t minus liquidity premium for t time periods and raise it to power 1. And then from this fraction, once you have the result, subtract 1, right? So remember this as a template. Let me write another one for you. If I have to forecast this interest rate, that what is the likely 1-year rate 2 years later, then watch how am I writing it. You will be able to identify a pattern. See, right? Are you able to see a pattern here? Let me write one more and then we will conclude this. So 3 years from now, what is the likely 1-year rate? I hope you have been able to identify a pattern here, which is that whatever the number I write here comes here. And whatever the number here, the next number is here. The same thing happening here. If I write 2 here, this 2 occurs here, 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 and 2 plus 1 appears here, here, and here. Just like that, if I write a 1 here, we could write here 1t if you wanted to. 1, 1, and 1 plus 1 appears here. So that leads us to a generic formula here, i.e. t plus, if we wanted to forecast n periods ahead, what would we write? 1 plus I, so we should write here n plus 1, so n plus 1t minus the liquidity premium for n plus 1t raised to the power n plus 1, and then divided by 1 plus I, will in the denominator the same number is there, so nt minus liquidity premium nt raised to the power n minus 1, right? So note this as your final generic form that can be used for forecasting any number of periods ahead. To use this, we will pick up problem number, from my book it is problem 15, but from yours, I don't know what it will be, if you have a different edition or something. So let me see if I can, just to save time here, because if I write this out, it'll take more time. Let me see if I can share the PowerPoint. Can you see that? This is the problem. If it is visible, please spend one moment to see what it wants you to do, and then we can look at the solution. Let's read it together. It says, if the interest rate on 1 to 5 year bonds are currently 4, 5, 6, 7, and 8%. So if I were to use the annotation tool here, these are all short-term rates, 5 short-term rates. So if you had to label them, this is the interest rate on a 1-year bond today. So IT. This is if you invest for 1 year, 1 year later, because this is 1 to 5 year bonds. This is for, I mean, investing for 2 years. So this is I2T. And this is I3T. I4T. And this is I5T. And the problem further says the term premiums are 0%, 0.25%, 0.35%, and 0.40%, and 0.50. What do these mean? These numbers here are telling you, they are telling you that if it is that we are investing for 1 year, we don't need a sweetener, we don't need something extra, no premium for liquidity is needed, 0%. But if you're asking us to invest for a period of 2 years, then we will demand something extra, which is liquidity premium for this, for investing for 2 periods. This is the liquidity premium, which will be a little bit more for investing in a 3-year bond. This is the liquidity premium for investing in a 4-year bond, because 4 years are greater than 3 years. So this is also a little higher, 0.4% as compared to 0.35%. And likewise, you can read this liquidity premium for investing in for 5 years. Given this information, they are asking us to predict what the 1-year interest rate will likely be 2 years from now. So this is what they're asking us to compute. On PowerPoint, I didn't find a way to type a superscript and a subscript simultaneously, but actually if you are writing it, you should write an E here too. Right, so what is the formula that we are going to use? IET plus 2 will be equal to what? 1 plus, in the numerator, whatever is the number here, 1 more than that is what we write here. raised to the power 3. And in the denominator, whatever is the number here, that is the number we write here. And then all that remains to be done is to substitute the numbers where they belong. So we will write 1 plus, what is I3T? The third year bonds. So we have labeled it already. See, I3T is coming to here, 6%. So we will write 0.06 minus the liquidity premium for the third year. So this is for the first year, this is second year, this is third year. But please be mindful when you are doing it. One common mistake is to write it as 0.35, which is going to be incorrect. See, it is 0.35%, so it will be written as, so 0.35, if you divide by 100, you will get 0.0035. So please remain mindful of this. And then raised to the third power. Then you should divide it by 1 plus the yield for 2 years here, I2T is, we have marked it already here. This is what it is, 5%. Minus the liquidity premium for investing for 2 years will be this one. So likewise, like in the numerator, be careful, 0.0025 and raised to the second power and minus 1, and the rest is your calculator business. If you will do it correct, your result should be 0.075, which will give you 7.5%. Right. So IT is equal to 4%. That's given. IET plus 1 can be calculated. We haven't done that because the question didn't ask us to. So it can be done. You can try as practice. What the question asked us to do was to calculate this, and this came out to be equal to 7.5%. You can verify this result on your own calculator to be sure and certain about it. That is pretty much it, ladies and gentlemen, and that takes us to the end of topic number 2. This is the conclusion of chapter 5 and topic number 2, unless you have questions that you would like to ask. If there are no questions, then we can conclude here, and I can wish you all the very best for the carnival. Have a safe one. Enjoy.
Sir,
Don't try to study anything during this break. Just enjoy and have a good time.
sir, excuse me.
Mhm.
Could you go back up the QR code, please, for attendance?
Okay, I can do that for you. Just give me a second. Some people in the chat are asking for the midterm, when that will be. Midterm will be after we finish 3 topics, which means 1 more chapter. After we are done with the next chapter, then we will discuss in class when would you like your midterm to be served, and then we can just fix a date which is mutually comfortable for everybody. So this is for your attendance. Let me know when you're done so that we can then sign off session.
Will the midterm be in person or online?
Sorry?
Will the midterm be in person or online?
Midterm, you tell me how you want it.
All right.
Sir, I got the attendance. Thank you.
Okay then. All right, folks, then it's bye-bye from my side. We'll meet again next Friday in class, hopefully. Till then, take good care and enjoy yourself. Bye-bye.
All right, so have a good day. I appreciate having the class online.
And no problems.